You know those headlines you see all the time? New study shows something that's either incredible or kind of scary. We're bombarded with them. But what do they actually mean? Well, today we're going to put together a toolkit that lets you look right past that headline and figure out what the research is really saying. Okay, let's get into it.
So let's start with a question that feels pretty real. A headline might yell, "Facebook tanks student GPAs." But if you're a researcher, your job isn't to yell. It's to figure out how you could possibly answer this question with cold, hard facts. This is going to be the central quest for our explainer today.
To answer any questions scientifically, you can't just, wing it. You need a plan. You need a map that's going to guide your whole investigation. And in the research world, we call this map a research strategy.
So here's the key thing to get. A research strategy is your overall plan of attack. It's not the tiny details yet, it's the big picture. And it is completely 100% dictated by the question you're asking. Are you just trying to describe something? Are you looking for a link? Or are you trying to prove that one thing causes another? Each of those needs a totally different strategy.
This table here basically lays out the 5 main roads a researcher can go down. You've got descriptive, correlational, experimental, and a couple of others. Now, they're all useful, but we're going to zero in on the 3 big ones that you're most likely to bump into when you're reading the news.
So, the first and maybe most fundamental strategy is all about just watching and describing. I mean, before we can explain why something is happening, we first have to get a good handle on what is happening. And that's the whole job of descriptive research.
This strategy really just paints a picture. It measures one thing, like hours of sleep, for a specific group and gives you a snapshot. Notice it's not explaining why they get that much sleep or what happens because of it. It just states the fact. This is what we saw. It's the essential starting block for everything else.
All right, let's move on because this next idea, it might be the single most important thing to understand if you want to be a critical thinker about research. It's the massive Grand Canyon-sized difference between seeing 2 things happen together and proving one of them makes the other happen.
And this slide just lays it out perfectly. On the left, you've got the correlational strategy. Think of it like a detective who notices that the same guy is always near the scene of the crime. Is it suspicious? Yeah, maybe, but it's not proof. On the right, the experimental strategy is like catching the suspect red-handed on video. It's designed to prove it.
Let's dig into that correlational strategy for a second. Its entire purpose is just to see if a relationship exists between 2 things. As one thing goes up, does the other go up too, or maybe it goes down? It's fantastic at finding patterns, but, and this is a huge but, it can't tell you why that pattern is there. Let's circle back to our Facebook question. A correlational study might survey 1,000 students and find a clear link. The more time they spend on Facebook, the lower their GPAs tend to be. A link is found, but it does not mean Facebook is causing the bad grades, right? Maybe students who are already struggling are the ones who use Facebook to procrastinate. We just don't know the reason.
Now, if you actually want to prove cause and effect, you've got to bring out the big guns, the experimental strategy. This is the gold standard. Here, researchers don't just sit back and watch. They get in there and actually change something on purpose just to see what happens.
A perfect example is an exercise study. You take a group of people, you'd make half of them start a new exercise routine while the other half just lives normally. Then you measure everyone's cholesterol. If the exercise group's cholesterol drops, well, you have some pretty powerful evidence that the exercise is what caused that change. You controlled the whole situation.
So, let's say a researcher picked a strategy, ran the study, and got some results. Awesome. But that brings us to the next absolutely crucial question. Are the results any good? This is where we have to talk about something called validity.
This is the question every good scientist and really every critical thinker has to ask themselves. Just because you have a result doesn't mean it's a real result or a meaningful one. You have to check its validity, and there are 2 main ways we do that.
Think of it like this. Internal validity is all about looking inward at the study itself, popping the hood, so to speak. Was it built right? Is the conclusion the only possible one? External validity is about looking outward. Do these results from this specific lab setting actually apply to anyone else out there in the real world?
So let's zoom in on internal validity. A study has high internal validity if it's basically airtight. You can say with confidence, yep, the thing we did is the one and only reason for the result we saw. You've sealed off all the other possible explanations.
And this is the core idea right here.
Any little factor that sneaks in and could offer a different explanation is a threat. We call them confounding variables. In that exercise study, what if the exercise group also, by chance, started eating healthier salads for lunch? Then you wouldn't know if it was the exercise or the diet that lowered their cholesterol. The results are confounded.
Okay, now for the other side of the coin, external validity. This is all about generalizability. It's like a bridge from the clean, controlled world of the study to the messy, complicated real world. The question is, can your findings actually make it across that bridge?
And here are the big ways that bridge can get shaky. Like, if your study only used college-aged men, can you really generalize the results to elderly women? That's a threat. Or if you did your study in a super quiet, sterile lab, will the results be the same in a busy, chaotic office? Maybe not. You always have to ask, how far can we stretch these findings before they snap?
Okay, so we've covered the main game plans and the essential quality checks. We have all the pieces we need. Now let's assemble them into a simple, really powerful toolkit you can use every single day.
The next time you see a news story about some study, just mentally run through this checklist. First, figure out what they were trying to do. Are they just describing something, finding a link, or are they claiming they proved causation? Then, hit them with the big one. How much can I really trust this? Are there other explanations? And does this even apply in the real world?
And that's really it. This isn't about being a cynic and dismissing all research. Not at all. It's about being an empowered, critical thinker who can tell the difference between solid science and shaky claims. You now have the basic framework to understand not just what a study says, but what it actually means. So I'll just leave you with this. When that next headline pops up on your screen, eating this one thing will change your life, you'll know exactly what to do. You won't just swallow it whole. You'll start asking questions. And that very first question you ask yourself, well, that's the beginning of you thinking like a real scientist.